So if you have a video and you don't want to share it, go ahead and remove it now. But on my screen, I know I think Zoom will record your videos. So go ahead and turn them off if you want to. And I will also share the link to this whiteboard you see on the screen, this mural. So you can just watch me there if it's going to be clearer for you. Click on my face here on the top right so you can follow my cursor and follow where I go. So I'll give you guys like 30 seconds to do that.
Yeah. Okay. Okay.
Okay. So last week, I talked about being able to, for the first time, being able to make a yield on a very, very small amount of money on Bitcoin use on the Lightning Network by providing liquidity. And then, that probably doesn't mean anything to you guys. Like it didn't mean anything to me then. But that's why I dove into, when I first read it, I was like, yeah, I want to make Bitcoin out of my Bitcoin, right? So how do I do that? So that's when I dove into the Lightning Network. I started reading about it, but even reading about it, like it still wasn't so clear. Even if you know the technical stuff, it wasn't so clear. And I think like what I've prepared, kind of prepared, like I'm still going to, I don't have any slides or anything, so I will be just talking from my experience. But what I'm going to explain to you today is what I think would have helped me understand how not just the high level of how Lightning Network works, but also what liquidity means, and I would have understood why it's important, right? All right. So Lightning Network. This is the thing that will allow Bitcoin to scale to theoretically to infinite transactions per second, and that works. Right? That's possible because it's doing the scaling in layers. It is not doing the scaling on the blockchain, on layer one. Right? It's doing it on layers, and this is how you'll see later. This is how the internet scaled as well, right? This is a perhaps a poor example of the Bitcoin. These are Bitcoin nodes, right? These are the diagrams for databases, and the way the layer one or the Bitcoin blockchain works is that any change in one propagates to everybody else. So if you have 10,000 of these database or these blockchain or Bitcoin nodes around the world, they have to know about the same transactions that the others know about, right? So this is why it can't scale so much. And when you try to scale things on this layer, on the base layer, you're going to start to see some issues like what I just saw this morning, like what Solana is seeing, right? So Solana is, the next hot altcoin, and I saw a post from, I don't know, their development team or something, maybe their foundation, saying that they were down, right? The whole network was down because at one point, like they reached 400,000 transactions a second, but then it started to affect certain nodes, like they started dropping off. So, they weren't syncing anymore with the rest of the network. And that's because if your internet connection is bad, then you won't be able to sync all those transactions. If your computer is too slow, you won't be able to check all those transactions and your node will start to lag behind. And if enough lag behind, then you can have a network split, right? So imagine a split like that, where these two are syncing things that people send to them, and these two are syncing something else. So that's what they call a network split or a fork. So it's important for layer one to be in consensus so that you know, hey, if it's on layer one, this is the real thing. Because when your network splits, you don't know, right? You don't know which one will be chosen. And that's why I think that the best way to scale really is doing it in layers. And this is what Lightning is. But let's start simple. So Lightning is based off of the idea of having channels between two nodes. So you have node A and node B, and they have a connection between them, right? And what happens is when you open up a channel with others, is that you put in some Bitcoin in that channel. So just so that it's easy, I am not going to go use decimals here. This is just, 1 Bitcoin, right? 2 Bitcoins, 3 Bitcoins. So this is A opens up a payment channel with B, right? And of course, A has its own, I want to bring this closer actually. A is talking to its own Bitcoin blockchain. Whoops. And so is B, right? B ideally talks to its own, because if you talk to the same one, then that one can lie to them both. So, and when the channel's open, A is basically creating a multi-sig contract, a 2 of 2 multi-signature contract with B. And by multi-sig, it means like, hey, we're doing this together. I have one key, you have the other. And when A wants to send Bitcoin to B over the Lightning Network, they don't have to write anything anymore after they open the channel. They don't have to write anything anymore to the layer one. It just sends a message to B saying, I am assigning a Bitcoin to you. So that's how it moves. Now B has one, right? And then maybe A is like, okay, I'm going to send another. So now B has 2. And then maybe...
Now, is this work done on the Bitcoin blockchain or on the Ethereum blockchain? How is this?
This is on Bitcoin. This is on Bitcoin. I know Lightning is also compatible with Litecoin, but I think there's really only there is the most of the activity is on the Bitcoin blockchain. I know Ethereum had its own thing back then called Raiden, where they were supposed to, I think they raised $30 million in an ICO. I don't know what happened to that. It looks like nothing happened to that. But I remember Vitalik talking about, basically, yeah, we have our own Lightning Network too. But the weird thing is, I guess with everything on Ethereum, it's like it has its own token. Everything has its own token. And I find that super confusing, right? So on Lightning, there is no separate token. The token is Bitcoin. So, and then when A sends to B, the last one, now everything's on B, right? And A cannot send anything more to B. And now only B can send to A. Okay, before I continue, questions? None? Okay. Now, you probably noticed a few things. This is not really worth it if it's just one channel, or if you had to create a channel with everybody you want to pay, right? So let's say I want to buy Bitcoin from my coffee shop. I also want to buy Bitcoin. I want to buy coffee from my local coffee shop, from the grocery. And if we're gonna do things on payment channels, then do I have to like, essentially lock up some Bitcoin for everybody I want to transact with? Doesn't sound very nice, right? So if you're gonna interact with 100 entities, then you're gonna be having 100 channels, and that's not scalable. Also, so that's why the Lightning Network. That's why the Lightning Network is called a network, and is because you can send Bitcoin to other nodes that you're not directly connected with. Right? I have a node, so let's say this is me, and you have just a bunch of others, A, D, E, C, G, F. And then you also have a centralized, or rather Lightning Network nodes that represent many users. So this Athena is the company behind the Chivo wallet in El Salvador. But this is what Strike would be as well. This is what Wallet of Satoshi would be. This is what Blue Wallet is. But not all Bitcoin Lightning wallets are like this. Some are like this, right? This is what Phoenix and Breeze would be. It's just you. It's your node, essentially, on your mobile phone. So how does this work, right? So let's say, let's not go Athena yet. Let's say I want to send to F, but I don't have a direct connection. So what do? I want to send, and I'm going to keep fees out of the equation for now, just to keep it simple. What I do is I have a picture of the whole graph, and I say, I can get to F from through A, and then to F. I can also get to F through C, right? And I can also get to F through G, and then to C, although that doesn't make sense anymore, but it might. It will here. But let's say I want to pass F. So I want to send one Bitcoin, moves that way, and then A says, okay, now F has received the Bitcoin. And this, by the way, isn't based on an honesty system. It is not possible for me to send to A, and then A says, thank you, but I'm not going to send to F. Good riddance, right? It's not like that. There is a secret, essentially, but I'm not gonna go into this now. There is a secret that I tell F, saying that that allows it to be atomic, meaning if A doesn't forward it to F, then this A won't be able to claim this Bitcoin. So just know that it is not possible for A to just not send to F, but get my Bitcoin. So that's how it works. Let's take another example. Let's say it's like this again. And a while ago, I said, hey, I want to get to F through C, my direct connection with C, but I can't because I don't have any Bitcoin on my side. So I'll be like, all right, I could go to G. G can send to C, and C can send to F. Right? You're getting a picture, a mental, well, not necessarily, but a picture of how, a little bit of how Lightning works now. Any questions?
Hello.
Yeah. Oh, sorry. Go ahead. Go ahead. No, please go
thank
ahead.
you. Yeah, I have a series of questions. A little bit. I'm in the advanced side of the questions. Who is presenting? MK Combs?
No, Ramon.
Ramon. Hi.
Ramon, yeah, hi.
Nice meeting you.
This guy.
I'm a first time listener, and fifth time joining these meetings.
Oh, really? Okay, you must have
Yes.
come in a different name because I
Yeah,
don't recognize you.
my name is in the top, Jairu.
Okay. Jairu, hi.
Yes. So I'm currently based in Tokyo. So I have a lot of questions about the group and the people that's joining and the mission of this group. But
Yeah.
the number of questions I had, the first one is, you mentioned that Athena is the group that is in charge of setting up the Chivo wallet in El Salvador. I believe
Yeah.
the team was Nicolas from France with a company called Galia or something. Galio.
Yeah. Um,
I think
yes,
those are.
yeah, this is, I don't know what Nicolas or what, yes, Ga something. I see his Twitter handle on in my mind, but I forget what the name of the company is. I don't know if he has anything to do with it, but what I read was that Athena is behind the Chiba wallet. I also don't know if Strike has anything to do with Athena.
You might be right, because sorry, I'm looking here. Galia is not the Chivo wallet, it's the Bitcoin wallet. So they have the Bitcoin wallet, the Bitcoin Beach wallet, and then they have the government wallet. So probably you are right, and Athena is the one that is in charge of the government wallet, the Chivo. I'm not very sure about that, but I know that there's another wallet also called the Bitcoin Beach wallet.
Yeah, yes.
And that one
that's right.
is developed by Nicolas, maintained by Nicolas' team, and the Galia. I forgot. I need to find out how you pronounce it exactly.
Yeah.
Okay, perfect. That's great. The second question is, did you or the team here had a chance to see the presentation about the Chivo wallet and how it's supposed to work? It was in Spanish, unfortunately. It was only in Spanish.
No.
So,
yeah,
okay.
Yeah, I haven't.
Oh, okay.
But
so
I don't know if
maybe
anyone else has. Yeah.
Yeah, but in the, I don't want to hijack the meeting, but last comment.
That's fine.
In the future, what I can do is I will try to show the presentation, share the screen and stuff, and explain what they're saying, or maybe summarize the topic.
Sure,
that would
be great. Yeah,
very good. What they were doing, the way they were setting it up. But again, I have a few questions about fees, balances,
yes,
things like that. And maybe we can take it offline, Ramon. I have a Twitter handle, and I have a YouTube channel where I teach about the Lightning Network and Bitcoin. So definitely looking forward to share notes.
Yeah, this is meant to be a very high level. I will talk about fees a little bit later here. And right now I'm already starting to introduce the concept of like remote and local balances. I'm still by saying, like, I couldn't send to C, right? So I had to go through G to get to C to get to F. Because I will talk about leasing liquidity in the Lightning Network. And that's how people can, well, I actually wouldn't recommend it for everybody, perhaps. But it is possible, right? And I've done it, but small amounts. And I want to explain why people are even paying for this, right? Like why, what is liquidity?
Why funding the channels is important, correct? Yeah.
So yes, please just ask anytime, right? We have till 12. I think that's more than enough time to talk about this. I'm probably over halfway through already.
Okay. Sorry to interrupt, but I'll let you continue.
No,
but I will definitely will be joining more of this group. And
to answer your question, this is just a general Bitcoin group. I created this in 2018 because I craved just Bitcoin discussions. Because then I had decided to focus on it and not
That's
not
great.
the altcoins anymore. Because even just in Bitcoin, there was so much I didn't know about.
Right.
And I couldn't spend a lot of my time reading white papers that my friends were asking me to read and understand so I could explain it to them. I have a technical background, that's why.
Yeah,
And
absolutely.
I think Bitcoin has the best chance of being it doesn't have to be the only one, but some kind of global reserve asset. And with what we're seeing with the Lightning Network, I don't see why it couldn't be a currency as well.
It is a currency in El
Or-
Salvador currently. So
Yeah, right. So
So-
exactly, yeah, and it wouldn't. I don't think it would have been possible without something like a Lightning Network. Like on layer one, this El Salvador wouldn't have been able to do what it's doing very effectively.
absolutely. Agree.
Yeah.
Well,
All right.
thanks.
So
Thanks for the
yeah, sure. Thank you for your questions. So now you have an idea. Like now I can't send to C anymore. I cannot send to G. If I wanted to send to C, looks like I could go through A to F to C, right? That's like it will work because I only have Bitcoin in this channel. So what I would do then is if I needed to okay, no, let me stop there. Let's look at a centralized system like what Chivo is in El Salvador. There, they have, I just put one node. I don't know if they exactly have one node only, but essentially the users have apps on their phones that just talk to some server, right? And here, I'll just put it as one node. And it's the operators of this Lightning node. It's their responsibility to make sure that there's enough liquidity. And by that, meaning, if a user of my system sends out, will they be able to? And the answer to that is yes, they can send out to F, it looks like. They can send out to A, right? And this is a super simple example because you'll want more than just 2 connections, especially if you're running a node this large. So if, let's say, Enjoy, her balance, Enjoy was the person in the last meetup we had. So I put her name here. If she wanted to send some of her Bitcoin, and let's say she has because it's an IOU, what she essentially has with Athena is an IOU. So Athena has a ledger. Let me bring up the ledger in some SQL database. Let's change this to Joy. Whoops. And let's say she has 5 Bitcoin now, right? That's times 0. If she wanted to send, let me delete this also. If she wanted to send 1 Bitcoin to A, then she'd instruct Athena to do so. Athena would send 1. And then Athena would now say her balance is 4. And B's balance hasn't changed, right? If she wants to send to B, then Athena doesn't even have to touch the Lightning Network. Her balance is now 3 and B's balance is 1, right? If, let's say, I want to send Joy 1 Bitcoin, then I would send A1, A would send Athena 1, and then Athena would say, you got Bitcoin from outside, so that's the balance now, right? So you'll notice that this is certainly one way to scale, but it's a centralized way. This is essentially what you are doing when you send, like on Binance, when you withdraw Bitcoin, but you deposit it into another Binance wallet. Binance, another Binance Bitcoin address Binance won't hit the chain just to send it to themselves. They'll just say like, oh, this address is ours. So instead of touching the chain, let's just deduct from Joy's balance, and let's increase this other address account balance. All right. Questions so far? Okay. I take silence as none. All right. Let's bring.
Sorry, Ramon. Just I think it's a good idea to explain what an IOU is. Maybe some people are not familiar. Just the concept.
Sure. Yeah. Okay. So just
also,
like a bank.
Ramon, excuse me.
Yes,
Are you
Carlos.
gonna touch on security at all on this?
No, not really. Like, how would you secure your Lightning node, something like that? No, but
no. How is the network itself secure? You know, the Lightning network.
Well, okay, that's a good question. Let me see. I'll answer that, or at least I'll attempt to answer that after the IOU. So an IOU is just like even a bank. Let's take an example we all know. When you deposit money to your bank, that those pesos aren't yours anymore. Those dollars aren't, I guess legally they're yours, but also it's just an IOU to you. The bank could go under and you might not get it back anymore. An IOU is as an IOU, right? But it's spelled I-O-N-U with the 3 letters. It's the bank's liability to you. In fact, the reason why like banks have a insurance is because if they do go under, then at least you know that this insurance company is good up to a certain amount. But the same way, if you're using a centralized or a service like Athena, the 4 Bitcoin that Joy has with Athena is just an IOU. She does not control the keys to those Bitcoin. The keys belong to Athena. So if Athena disappears, and this is what I was saying earlier, if they disappear because of a hack, right? Or perhaps they, the government decides to rug pull, as they say, to rug pull everybody and take their Bitcoins on Athena, then Joy would not have her Bitcoin anymore. There is a saying, not your keys, not your coins. Like if you don't have the keys to control the Bitcoin, then it's an IOU.
Right. Just to add to Ramon, maybe if I may add, is basically it's like in the Lightning Network, as he mentioned before. This is happening on the layer 2 of this system. Layer 1 will be the Bitcoin blockchain, where everything settles there forever once it's written in the blockchain. So Lightning Network uses IOUs, which is just agreements. I send you some sats, you send me some sats, everybody's sending different sats each other, and then we agree, and I'm sending you this amount of sats, you have them. But nothing is written yet on the blockchain until it's settled.
Right. Nothing. Yeah, that's right. We only write something on the blockchain when we open a channel, because we're creating a multi-sig transaction together, and then when we close it, because we need to say, hey, like we're closing this multi-sig transaction and sending the corresponding balances to ourselves. But it is not just like I guess I want to make sure that people don't think that the Lightning Network is just IOUs. Like in a certain level, yes, it makes you could call them IOUs. But there is a security model behind this, and this might be related to Carlos's question, is that this is one channel together, right? This channel has 3 Bitcoins in it. But Ramon, I cannot just say, give all of that to me. That's all mine, right? It's an IOU anyway. So if we have one key each, I can take them all. It doesn't work that way. The way it works is A knows, like, A has cryptographic assurances that these two is theirs. And I have an assurance that in this channel, one is mine. If A sends me one, they're essentially sending me the like, in a way, assigning that to me cryptographically. So now I have cryptographic assurances that I have these two, right? Now, there are some nuances, but I won't get into that. But I won't get into that now. Perhaps in a future one, but I'll have to brush up on the cryptography behind it again. But as you could see, security-wise, if I get hacked, it doesn't affect A in a sense that A's Bitcoin in our channel gets stolen. And it certainly won't affect F or G, right? A and E and C will be inconvenienced because, maybe my node went down, but their Bitcoin and their Bitcoin might, like, they'll be able to receive their Bitcoin on chain, meaning on the base layer, like a few days later. So it gets like stuck for a little bit when you close the channel. But they don't lose it, right? I don't know if that answers the security question, Carlos. I don't hear anything. I don't know if you're muted, but I'll keep going. And you may have noticed also that if I want to make a payment to F, you remember this, the Bitcoin would travel from me to C, from C to F. None of the other nodes know about this. E doesn't know about this. G doesn't know about this. D or A don't know about this. C would know about it, yes, that a payment came from me to get to F, but none of the other nodes do. None of their databases get written to. So the data only traveled from me to C to F. That's it. So we don't have the problem with the base layer where everybody has to stay in sync. One more thing, right? So how about privacy? Like, what if let's think of something, a farther route. What if Athena wants to pay G? What the way the cryptography that Lightning uses is also similar to the Tor network. So the Tor network is a private way, a more private way to browse. It's like, I think if you've heard the term dark web, that's essentially Tor. It's like you get the Tor by using something like a Tor browser, then you can start browsing Tor websites. But the way Tor works is that when you connect to your final destination, you go through servers in between. But each server only knows about the next server it's going to send it to. So I'll show you how it works in the Lightning Network. If Athena wanted to pay G, and then Athena would say, okay, I'm going to make a transaction that's going to go through A, that's going to go to F, that's going to go to C, and it's going to go to G. But that transaction, I'm going to wrap it in cryptography so that when I send that instruction to A, right, 1 Bitcoin, A sees, okay, I mean, obviously that it came from Athena, right? But all A can see is that it needs to send to F. It doesn't know that after F, it's going to go to C. So let's do that. It's with F now. All F sees when they decrypt that transaction is that it came from A and it needs to go to C. It doesn't know that before A, it came from Athena. And it doesn't know, just like A didn't know, 2 steps after, it doesn't know that after C, it goes to G. So let's send that. And it's the same for C also. C only knows that it came from F. C doesn't know that it came from originally from A or even from Athena. And C knows it just goes to G. And C also doesn't know necessarily because there might be some tricks to find out. C doesn't necessarily know that G is the last destination. So let's send it to G. There. So that's how it can be private, right? Like you only know, F only knows where it came from and the next step. It doesn't know the final destination necessarily. Questions so far? Carlos, did I answer your security question?
And
anyway,
and Ramon,
go.
I don't know if he went away or he went in mute, but I will also mention it's good. I know it can be we can go very deep on details here and technical,
Yeah,
but
yeah.
It's good to mention that in terms of the concerns about security. So first, it's good to understand that the LND code and Bitcoin is one of the most secure networks out there, especially the Bitcoin network. The LND and the LND is the other application that is developed or the main component of the Lightning Network. One of the components of the Lightning Network. The other one is C Lightning, but that's another topic. And then we have for C Lightning and LND are open source projects, and they maintain, they're secure. And then of course, in terms of security, we need to make sure that we keep eye on it, make sure that they are up to date, and there are no any vulnerabilities reported, and then we had to upgrade the versions and things like that. Yes. But also the Lightning Network also have some mechanism that when another node or another user or bad actor try to do something funny, like trying to get the satoshis from another person or from another node, they will get also, there's a mechanism in the Lightning Network that will apply a penalty to them, in which at the end the user can retrieve their satoshis, plus the person that is trying to do the hacking will lose all the satoshis, right? On the other end.
Yes, that's right. But I also agree that that becomes a little more, that's more complicated to explain, because there is we have to go into technical details to talk about what data is being exchanged in between, and also the how penalty transactions work. And also like there's even this thing called watchtower, right? But let me try to say it in 1 or 2 sentences. When 2 nodes pass Bitcoin to one another, what they're exchanging is the state of that channel. Like 1's with me, 2 is with you, right? Or in this case, since this is my node, 2 is with me, 1 is with you. And A saying, yes, 1 is with me, 2 is with you. But then as we start passing around, I'll be like, 1 is with me, 2 is with you, and they agree. But we also have the old state, right? We also have, like, A has the data that says 1 is with me, 2 is with you. But I also have that too, when 2 used to be with me and 1 was with A. So you might think, hey, what if I take the old state where 2 was with me and 1 was with you, and I publish that and I send it to the blockchain. I'll also be like, so that on the blockchain, I will receive 2 and A only gets that 1. And I win, right? Well, yeah, there is a way for A to detect this and in a way contest this. And it, and not just contest, but if I do this, A can take all the Bitcoin in the channel. Right? So the incentive for me, to be honest, is high. Because because I'll also lose mine, right? The Bitcoin on that channel that is mine.
So, Ramon.
Yeah.
A does know that it is connected to U and to D and to F, right? It knows that.
Yes.
So it's like a router in a way.
Yes, exactly.
But the thing is, in a router, everybody knows what the destination address is, right?
Yeah.
So in this
But not
case,
here.
what you were saying was the destination address is unknown to each of these nodes.
Yeah. Let's say Athena, right? Like our example earlier, but I won't move the Bitcoin around anymore because that takes time. Athena wants to send to G. Athena knows the destination because it needs to prepare something for G to accept, right?
Right.
But as it passes that around, the nodes in between, and they're called routing nodes. So yes, you're right. The routing nodes in between don't know anything beyond the first step before and the next step. So the step before and the step after, they don't know anything else.
Mm-hmm. So the route is then, I believe, it's predetermined. In the internet, the routing is not predetermined. Each router tries to get to what the next stop should be based on how fast it could get to the destination point.
Yes.
It looks at the destination and looks at the
Yes.
situation and sends it to the next node, which it thinks would be the fastest way.
Yeah, it's kind of like that. So you're going into graph theory now. Like if you have a weight here, and a weight is a number. Let's say this is the internet, right? So Athena is let's say Athena's like a Google, and this is me in the Philippines. If I want to talk to Google, I probably jump through Singtel, or no, well, actually there's one in between. Let's say this is me in the Philippines. I go to PLDT, and then PLDT, maybe has a connection to Singtel, and then Singtel has a connection to Google. Something like that, right? I'm simplifying it. So it jumps through. But E could potentially go some other route, like maybe it'll use an undersea cable somewhere else, right, to get to Google. That's also how the Lightning Network works, because the weights in each of these connections, though, isn't like what undersea cables exist, but rather, one is their Bitcoin on our side where we need it, right, on the side of the channel. So if Athena wants to send, just do this so that I don't have to move stuff around. If I want to send to G, can I pass this route? I can't. So I can pass this route. I cannot pass this route either. So my node scans all this stuff. And if I want to make a payment to G, it'll make the best guess, or it'll construct routes that it could take, or it might potentially take, because it's not just the liquidity. It's not just the Bitcoin on this side, because I haven't talked about fees yet. It's not going to, so this is the only route I can take. And then it looks like I won't move Bitcoin around, but it looks like I can go to A to go to Athena, to go to F, to go to C, to get to G, or I can go from to A to F, and that's shorter. So on the surface, that looks better, right? My node will probably take that first. we'll try that. But if it fails somewhere there, then my node will try to go past Athena. Right? You want to talk about fees before we wrap up? But super simple, okay? And fees on Lightning tend to be very small, but just because of the nature of the whiteboard and the images here, I'm gonna make the fees expensive in this example. So these nodes in the middle who are passing Bitcoin around, most of them aren't doing it, in the goodness of their hearts, right? They have expenses. They have to run the computer. They have to, if they're doing their job well, they have to make sure they have liquidity, right? Like F here knows that there's no Bitcoin on their side. So to get to Athena, they have to pass somewhere else. So, a question that F, if they want to be an effective routing node, is like, should I put Bitcoin on this side somehow? A little more to that later. So these are not doing it for free and they charge a fee. So let's say C says, if anyone's going to send through F, through this connection, I am going to charge them 1 Bitcoin. If anyone's going to send through this connection, I'm going to charge them 2 Bitcoin. Right? So now G knows that if it wants to get to A, this route is expensive. So how about we try this route first, right? How much do they charge? 1 Bitcoin, right? So let's say F, just to make the example simple, let's say F doesn't charge any Bitcoin, but C charges 2 for the use of this channel. C charges 1 Bitcoin for the use. So if G wants to send 1 Bitcoin to A, then G has to send 2 here. And then C says, okay, I'm just going to send 1 over to F, right? Because the extra Bitcoin that it got, that's its fee. And then F, since it charges nothing, it just sends 1 to A. Now, so there are 2 things to watch out for. Is there enough liquidity, right, on the side we need it to be? Like in this example, I can receive from G, so that's great. But I cannot send to G using this channel. And the second one is what the fees are of the routing nodes, right? So for example, if C is charging a lot, they're charging 1 Bitcoin to use this, then I might be like, hey, I can be a better connection for you. So I am going to connect to F. And I'm making this channel, right? I'm gonna put in Bitcoin there. And now, hey, G, because G has like a snapshot of the whole network. G can now see that I have a connection with F and I'm only charging 1 Bitcoin instead of 2. So then G's node will be like, hey, next time I want to pay F, I'm gonna avoid, next time I want to get to node F, right? Whether it's to get to some other node or not, I want to avoid this one because that's charging 2 Bitcoin. This looks like a better option. It's only charging 1. And so it'll do that. Oops. Nope. There. Right. And then because I charge 1, I'll only send 1 forward. Something like that. Okay. So what's this lending liquidity over the Lightning Network? Let's say someone joins in and they have a node. Well, they're not joined yet. They can open, right? As long as they have Bitcoin on the blockchain, they can open a connection with others. So they can open a connection with A. And let's say they put in To open the channel, they put in 2 Bitcoin. And then they can be like, hey, I want to make a connection to G as well. And then they put in the Bitcoin, right? Because if you open the channel, unless the other side agrees with you, you put in the Bitcoin. So it's easy to create new channels, but the problem is more often than not, the liquidity is on your side. And I say more often than not because G could ring up, H could call G. Let's say they have the email, the phone number. Say, hey, you want to open a channel together? Let's put 1 Bitcoin each. That's possible. But for a lot of nodes, you don't just talk to them that way, right? But you could open a channel without asking them in advance, except that without coordination, only you put the Bitcoin in. So what if H was a cafe and they wanted to accept Bitcoin payments or Lightning payments? They couldn't because A couldn't send to H. G can't send to H because all the Bitcoins on their side. So if C was a customer of the coffee shop H, let's just call it coffee shop, C couldn't make a payment to the coffee shop, right? I can't. No one can. So there is this idea of leasing liquidity where there's services that connect you together, where some nodes advertise, like let's say I advertise. I'm telling everybody, hey, I'll open a channel with you and I'll put, I'll charge you whatever, 6% per annum, right? I'll put the Bitcoin in, but you pay me 6% of that Bitcoin. Let's say it's a whole year that I say I'm going to keep the channel on for a whole year. And not just say, like there's some assurances here. So then coffee shops like, yeah, okay, 1 Bitcoin and you'll get 6% extra, right? I'll pay you to open this channel with me. So what I do is that I put 1 whole Bitcoin and suddenly coffee shop through me can accept Bitcoin. I can accept payments in the Lightning Network. And I do that again, not because of through the goodness of my heart, but because coffee shop is paying me a yield. And then now if C wants to pay coffee shop, I'm going to remove fees now just to make it simple. Then they can send to me, and then they can send to the coffee shop. Right?
When they send these Bitcoin, the Bitcoin now belong to you, Ramon, right?
If in this example, like when C wants to pay the coffee shop 1 Bitcoin.
Yeah.
Yeah. I now have Bitcoin on this.
And it doesn't belong to C
didn't.
anymore, right?
No more. And then
so it's an actual payment.
Yes, it's a payment.
Okay.
And then I send it to the coffee shop. Right. So I have none on this side. So the coffee shop now has liquidity problems because they can't get paid again. But they can open another channel, but this one is a bit contrived because it's not like coffee will cost 1 Bitcoin.
Now, you were telling us that there was this service where they take your Bitcoins and they pay you interest.
Yeah, that's
the one.
But
there's no counterparty risk because
yeah.
How is there no counterparty risk?
Because so in this example, so before we created this channel, coffee shop was saying, okay, I would say I'm willing to open channels with you, and it's using some service to broadcast this message, right?
Mm-hmm.
I'm willing to open channels with you. I'm going to put in 1 Bitcoin, and this is the rate I'm charging. So, and if coffee shops like, hey, yes, I need to be able to accept Bitcoin, so I'm willing to pay that 6% for the year to have that inbound liquidity. And by inbound, meaning they can now receive Bitcoin. Then I open a channel, but the Bitcoin is still on my side.
There.
it's still on my
Yeah.
side, right? So there's no counterparty risk, but I'm already going to get paid to just open the channel. And if
But
anybody
how does that help
routes,
the coffee shop
they can accept Lightning payments now.
from you?
Yeah, well, anyone connected to me. So if I'm doing my job well, then
Oh,
I have a lot of
from
people with the same
anyone
stuff.
connected to you.
Yeah. So you want to have inbound liquidity from
I
nodes
get
that are
it.
connected
Yeah,
properly.
yeah, I get it.
So coffee shop doesn't need to open with everybody. They just connect to one or two nodes
So,
that
so if C
are
wants
well
to pay the
connected.
coffee shop.
Yeah.
C sends its Bitcoin to you,
Yep.
and then
And
you
then
send your Bitcoin to the coffee shop,
That's it. Yep.
and you have no counterparty risk because you just got a Bitcoin.
Yes.
I like it.
Yeah.
I didn't understand it until this very moment.
Yeah. And I waited for the last 3 minutes to explain this, but that's how leasing liquidity works. And it's not the only way to get liquidity. Like you can go to an exchange that supports Lightning and sell your USDT there, or even sell, quote unquote, sell Bitcoin, but you say you want to receive it as Lightning, and then they're going to open a channel with you or send it to you somehow, right? Through the Lightning network. Well,
Mhm.
yeah, probably open a channel with you. So it is possible to do it that way as well. But this is the most straightforward way that I've seen. I mean, straightforward for technical people, but I expect it to get easier in the future.
Mhm.
Yeah. Well, that's it. It
Pretty
looked like
amazing.
it got to some of you, but yeah, to me, like this is how the internet scaled, right? And I think that Lightning will be able to scale also pretty well. You'll still notice that each of these channels have one transaction to open and one transaction to close it. But with Taproot coming in November, and then after that is Graftroot, and then I think there's even something else. Yeah, there is something else that's still being planned for and being worked on that will allow many channels to be created from one on-chain transaction. Like theoretically, you can make like 100 channels using one on-chain transaction. So if you want to get to 1 billion people, that is one way. We don't necessarily have to pass through the centralized way. We can still do it another way, right?
Mhm.
Okay.
Thank
I'm
you
gonna
very
stop
much,
sharing.
Ramon. This was very worthwhile.
Thank you, Ramon.
Thank you. I hope so. Again, I'll see you in 2 weeks. Thank you, JC. And let me stop recording.